Highly efficient and super cheap to run.
generating over 1,000 watts,
is the fantastic Liam F1 wind turbine.
and is extremely efficient.
YouTube is filled with videos about the Liam F1 Archimedes wind turbine. But the problem with urban wind electricity generation isn't just about blade design. Don't fall for the hype. This video explains why conventional small wind turbines have historically performed poorly in cities and low-altitude locations. Small wind turbines often struggle in cities because buildings and other structures disrupt the wind. This leads to slower and more chaotic airflow, making it hard for turbines to work efficiently. According to studies by the International Energy Agency's Wind Task 27, wind in cities is much slower and choppier than in open areas. In cities, wind speeds can be 30 to 40% lower, and the air can be up to 50 to 100% more turbulent. Turbulence means the wind becomes messy and unpredictable, swirling in different directions because of obstacles like buildings or hills. For wind turbines, this is bad because their blades need smooth, steady wind to spin efficiently. Turbulence shakes the blades unevenly, causing extra wear and tear that can break parts over time. It also makes the turbine produce less electricity because the inconsistent wind doesn't push the blades as powerfully. In cities, where buildings create lots of turbulence, turbines struggle even more compared to open areas with calmer winds. Most small wind turbines need wind speeds of 3 or 4 meters per second to start working, and they perform best when wind speeds reach 10 to 12 meters per second. However, in urban areas, the average wind speed is only 2 to 5 meters per second. This means these turbines often do not get enough wind to perform at their best. As a result, many home wind turbines, including the Archimedes Liam F1, will produce only 10 to 30% of their expected energy, making them less cost-effective for most users. For better performance in cities, it's essential to carefully assess local wind conditions and consider turbine designs that can handle turbulent, low-speed winds. The Archimedes wind turbine has a unique look and works differently from most wind turbines. Instead of using big spinning blades like traditional turbines, it employs a spiral shape, kind of like a 3D screw. This design is inspired by the Archimedes spiral. So what makes it special? First, it can start generating electricity with very low wind, just 2 meters per second. It's also quiet, operating at under 45 decibels even at full speed. Plus, it doesn't need to turn to face the wind. Its spiral shape allows it to capture wind from any direction, which is great in cities where the wind frequently changes direction. It's also safer for birds and bats, looks more stylish for homes, and performs better in gusty or unpredictable wind conditions. But it's not perfect. Compared to large, well-placed turbines, it's less efficient. It also costs more per kilowatt of power, and since the technology is still new, there isn't a lot of long-term data on its durability. It doesn't perform as well in areas with steady, strong winds, and it's more complicated to build. According to the company's brochure, their AWM-2000 model, with a 2-meter rotor, can produce up to 2 kilowatts. In areas with average wind speeds of 5 meters per second, it can generate about 3,600 kilowatt-hours per year, better than many small turbines in similar conditions. The company is also working on bigger and smarter versions, such as a 10-kilowatt model for businesses, solar wind hybrids, turbines designed to integrate into buildings, and models equipped with smart energy system connectivity. However, all of this is theoretical for now because the product isn't mass-produced or widely sold at the moment. In my previous video about the Liam F1 wind turbine, I received quite a bit of backlash in the comments. Many viewers argued that there wasn't a real comparison and noted issues such as there's no sun at night, implying that wind generators might perform better in some cases. Let me clarify. This is a home wind turbine we're discussing. In real-life situations where the wind blows continuously, traditional wind turbines can actually outperform the Liam F1. The criticism also touched on the lack of long-term tests, a valid point since these turbines aren't widely used yet. Without extensive field tests, it's hard to compare them directly to solar panels or conventional wind turbines. Compared to other home wind turbines, this design often falls short. You can watch a video comparing 5 new wind turbines on my channel using the provided link. When comparing wind turbines to solar panels for home use, solar panels typically come out ahead. Solar panels provide more consistent energy output and are usually more cost-effective for homeowners. They require less maintenance and have a longer track record of reliability. As always, the truth lies somewhere in between. If you have the financial ability, buying both a PV panel and a wind turbine will 100% provide you with a complete off-grid solution. The official Archimedes website doesn't list prices or offer a direct way to purchase their turbines. The contact link just redirects to the same page, making it hard to determine the true cost of a genuine Archimedes product. Some sellers on platforms like AliExpress and Amazon offer turbines that look similar, but it's unclear if these are lower quality copies. In some cases, sellers list outputs of 10 watts, even though the original product ranges from models like AWM-750D with 125 watts to AWM-1500D with 700 watts. These products on marketplaces like Amazon or eBay may end up being just useless toys. I've also found another manufacturer of Archimedes-style vertical wind turbines, a Chinese factory called Nantong R and X Energy. Their technical data is even more impressive than what is shown on the Archimedes website, with models ranging from 1 to 10 kilowatts. I sent them an inquiry, and they responded that a 10 kilowatt turbine is priced at about $4,700 for the turbine alone. However, when you factor in necessary components like batteries, inverters, and the hybrid control system, a full 10 kilowatt installation can cost between $10,000 and $15,000. These figures are based on a Chinese manufacturer's pricing, and further considerations regarding certification, quality control, and warranty support may apply. If these technical characteristics are true, we might see these turbines on our roofs worldwide soon. Don't forget to subscribe to my channel for updates on this technology. This impressive wind generator is still in its early stages, so you could be among the first to try an off-grid installation using the Archimedes wind turbine. However, the turbine does not seem to be widely available yet, and you might face challenges such as reliability issues or even no power output, as noted by the manufacturer. I have previously posted videos about 5 alternative turbines for home use. You can check them out in my latest video, or click the hint in this video. Don't forget to like and subscribe to stay updated on news about the Liam F1 Archimedes wind turbine.